Alright, today we're going to talk about continuity at a point. And we say that a function is continuous at C if f of C exists. And so what I'm talking about is the point. There's actual point there. There's no hole. So, for example, if I have a function, maybe that's an ugly axis. If I have a function, I don't have some sort of hole located at C. The point is actually there. Number two says the limit as x approaches c of f of x exists, and so essentially we've been talking about this for the past couple days. Is we have a left and a right limit, and that left and right limit is actually equal in the same value. So here's an example where that fails to be true. And so here I have it's approaching, looks like, we'll say this is 1, and we'll say this is -1. And so at C, my limit from the left, which is approaching 1, does not equal my limit at C from the right-hand side equals -1. So notice those two values aren't meeting up in the same place. And so you can actually see on the graph my limits aren't even coming close to each other. There's my first, here's my first one, here's my second one, and they're nowhere near each other. And so that would be an example of failure. An example that would pass oops, that's not the stroke color I wanted. Would be something like that. Notice that my left-hand limit is going to the same spot as my right-hand limit. They're both sides are approaching 1. The last one is I have a point. I have a y-coordinate. I have a limit that's coming at the same spot. Well, number 3 says that my point and my limit are approaching at the same value. So here's an example of what I mean. So here's my f of x. There's my hole. And we'll say this is located at 1, this is located at 2, here's C. Well, my f of C is equal to 2. That's where my point is located. My limit as x approaches C of f of x is equal to 1. Well, these two numbers are not equivalent. My point is at 2, my limit is at 1. I essentially have a jump. And that's what number 3 is talking about. My point actually has to be at the same position where my limit is. So, an example of that would look like this. Whoops. That's not what I want to do. There's my limit. Let me fill there's my point. My limit and my point are at the same spot for C. So my f of C is equal to 1, and my limit as x approaches C of f of x is also equal to 1. Some properties for continuity are if I have a continuous function, let's say f of x is equal to x, so here we go, here y is equal to x. Then if I multiply any number by that, any constant number, such as 3, that's also going to be continuous. Number 2 talks about if I have two functions, let's say x and let's say the other one is x squared. If I add, x squared is also continuous. If I add x and x squared together, I'm going to have another continuous function. The same is true if I subtract. Number 3 states if I multiply x and x squared, that means that x times x squared is also going to be continuous. That'll be x to the third, which is also continuous. Number 4 is a little bit tricky. If I divide x divided by x squared, two different functions, this is only true if a certain condition applies. And so if I have f divided by g, which is equal to is x divided by x squared. This is true only at values assuming that my c is not located at a vertical asymptote or a hole. And so if you remember, in order to create a vertical asymptote, that's where my denominator has to be equal to 0. So as long as c does not make my denominator equal to 0, I'm good. Number 5, if f of g are continuous, then f of g of x is continuous. So this is our composite function. If I plug in g of x into f, so g of x is x squared, if I plug that in, then my f is continuous, my g is continuous. If I plug in one function into the other, then that composite function is also continuous. Alright, let's go through several examples. For the first one, they want to know, for the first three, we want to talk about how is continuity destroyed at c. And so for the first one, my c is located at x is equal to 1. So my c is at 1. And notice that my point exists, and that's a good thing. My point's located at 1, 5. And so number 1 of my conditions to show continuity applies. So f of c is f of 1, which is equal to 5. So we're good there. That's fine. So now the next one we need to check is, does the limit from the left equal the limit from the right? Essentially, does my limit at c exists? And if you notice, my limit as x approaches c, we'll go ahead and actually write that value, as x approaches c equals, we'll go ahead and write 1, from the right of f of x, that's equal to 5. If you look at the left-hand side, my limit is approaching 3. We'll have a problem here because my limit is approaching two different values. These two values are not the same. And so essentially my function is discontinuous at x is equal to 1 because I have a jump. I go from 3 and then I jump up to 5. And so we would go ahead and write the limit as x approaches 1 from the left of f of x does not equal the limit as x approaches 1 from the right of f of x. Alright, let's move on to number 2. And again, let's go through each one of those. So the first one is, do I have a point? And the answer is yes. I have a point at 2, 7, which is good. And so my f of c, in this case, will be f of 2, is equal to 7. So my first condition is met. My next condition is, does the limit as x approaches 2 on the left equal the same as the right? So if you hear we're coming in from the left, and now we're coming in from the right, am I ending up at the same spot? And the answer is yes. And so we can say the limit as x approaches 2 from the left of f of x is equal to 5, and that is equal to the limit as x approaches 2 from the right of f of x, which is also 5. So we're good there. My limits are coming to the same spot. My problem occurs in number 3. I want 5 to equal 7. Well, it doesn't, as you know. And so our limit as x approaches 2 of f of x, which is equal to 5, does not equal f of 2, which is 7. And so that's my point is not located where my line is. It's jumping up to some two units up. And number 3, well, I can look at it and see I don't have a point. There's nothing here. I have a hole at 2, 5. And so my first condition is completely failed. My f of c doesn't even exist. There is no f of c. There's a hole there. And so it fails the first one.